So my name is Jacob Rindler. I'm the general manager for our Castheon business unit out here in Thousand Oaks, California, where we are the metal additive manufacturing specialist for the ADDMAN Group. So in this role, I lead our engineering and operations team, and some of the things that our team delivers to the customer is really, a big focus is space propulsion and propulsion in general. And some of the things that we send are items like this. With this is a thruster for a small in-space propulsion unit. This is basically what makes a satellite, what directs the thrust coming out of an engine to make a satellite move into a certain orbit. This could be, low Earth orbit, geosynchronous orbit, or any other orbit our customer desires. And with that, it can also be used for place maintenance, so making sure it's in the right place over time so it doesn't drift out of that orbit. And then also, as space debris becomes an issue, it's also able to do avoidance maneuvers. Say if we see something crashing into it, it's able to now quickly get out of the way to save that high value asset. So why is additive manufacturing, and let me put it in here close to the camera, why is additive manufacturing such a great tool for this? One, some of these materials that's printed out of, especially Niobium C103, is really hard to source. And so we take sometimes year-long lead times for raw material that they're going to machine down and pare it down to be able to print something in 4 to 6 weeks. And then, on top of that, some of these materials are quite expensive. And so we reduce the buy to fly ratio, or how much you're buying to how much you're turning into waste, down to very little, which is also very beneficial. And then also, it allows our customers to quickly iterate through their designs. So maybe they don't know exactly what they need, and now they're going to print something, and then they're going to weld it up to their final assembly. They're going to test it, and then they're going to change the design, and they're going to iterate through that a few times. And now, instead of having to wait a year to do that and get one shot at it, now they can quickly iterate, test and optimize, and get to the final configuration that they need. And that's enabled by the 3D printing. And how Castheon really does it is, we're a material-centric manufacturer. And so we are able to provide the best material and the best capability, in addition with that agility for their engineering products and their engineering timelines. There's also applications for the military, so systems and armament systems that need to quickly change, alter, or maintain their position or direction can use these type of thrusters as well to quickly alter the direction. Say it's a missile, for instance, that's taking off from a boat. It quickly needs to orient and start going in the right direction. Well, some of these thrusters can quickly burn off and get that object pointing in the right direction, so its main propulsive unit can now get it to where it needs to go. So that's also a big application for what we do. In addition, there are systems within that basically a thruster is always attached to a system that's generating a lot of hot gas. Typically, that hot gas needs to be contained and directed within a vehicle, and additive manufacturing is a really good manufacturing technology for pretty much anything that's handling fluids and needs to direct it into an area, direct it into a location, and do it in a pretty small form factor. That's where additive manufacturing is especially beneficial as well, from the design freedom that it enables. You can make a part that has a lot of functionality in a small kind of form factor. So not only are we able to help people through their development timelines, but also through series production. Because it's a digital manufacturing process, it's highly repeatable, i.e., we load files in the machine, and the machine knows to make the same thing over and over again. In addition to that, we have specifications around the material and the feedstocks and the processes put into place and recorded. So that way, now when you talk about needing to make the same thing over and over again, well, because we have all those things locked down and documented, we're able to take almost like a snapshot in time and repeat it further down the down the road as well. So when people are worried about obsolescence, now that everything's captured digitally, it's less of relying on, say, kind of the quote unquote tribal knowledge of a certain craftsman or group done periods of time ago. Also now, because it's digital, we have the file and the geometry. It's no going back to, say just like a drawing, right? We know exactly what was made, and it's not, kind of photocopied